Okay, the last little bit. 7.5. Section 7.5, what we are going to do is we are going to multiply and divide expressions we're going to multiply and divide expressions involving radicals. So once again, I just want to draw on stuff you already know how to do and apply it, because I know these radicals and doing things is new and different. So let's think back, way back machine. Let's say that you had 3 times, and then let's go 2x plus 5. Keep the numbers nice and relaxed. So you have a 3 outside the parentheses, you have a 2x plus 5 inside the parentheses. Okay. Well, what do I do with this? How do I simplify this? Yeah, that's called the distributive property, distribute. And distributing means I take this 3 outside and I multiply that 3 times each of the terms. So 3 times 2x is 6x, 3 times 5 is 15. Well, I'm hoping that this flickers a memory. You remember distributing. So that now we're going to do the same thing just with something involving a radical. So for instance, here's the problem. Let's say that I have the square root of 5 times 2 times the square root of 3 plus the square root of 6. So once again, I'm going to distribute. And just remember this, the product rule of radicals. Something's outside the radical, you multiply by other stuff outside. If something's inside the radical, you multiply by other stuff inside. Okay, you don't cross over. Outsides with outsides, insides with insides. Okay, so here we go. Square root of 5 times 2 square root of 3 when I go to distribute. Well, first off, what do I have outside the radical? I've got square root of 5, 2 square root of 3. When I multiply, what's outside? 2. Yeah, there's a 1 here, just like with a variable. So 1 times 2 is 2. What do I have under the radical when I multiply? Square root of 15. Great. 2 square root of 15. That's the first term. And then I'll do the same thing with the second. Square root of 5 times the square root of 6. Well, those are both under the radical. So I have plus what? I know you mean the right thing, but let's say it right, just so that we don't get into bad habit. It's not 30. It is square root of 30. Yes. Okay, put that under the radical. There you go. That's it. Something you already know how to do. You know how to distribute. The new thing is we talked earlier today about the product rule of radicals, so we're just applying that to this situation. Okay, so here's one for you. I've got a couple that you're going to do, and then we'll move on to the next thing. We're just looking at things that we already have seen and know how to do. So here's yours: square root of 10 times 4 square root of 3 minus square root of 7. Almost the same problem we just did together. You're just doing it on your own now. Multiply stuff outside with other stuff outside. You multiply the stuff under with other stuff under. So here you go. Square root of 10 times 4 square root of 3. Well, I've got a 4 outside the radical, and then square root of 10 times square root of 3 is square root of 30. Anybody get something different we need to talk about? Minus square root of 10 times square root of 7. Those are both under the radical. So the square root of 10 times 7 is the square root of 70, and we're done. None of those radicals simplify. That is something, some of the problems we do that might happen. The last thing I'll mention, that's not part of this problem, but always make sure that you simplify your radicals if you can. So if you notice a number that has a factor that's on the perfect square list, then you simplify it. That doesn't happen in this problem, so we can move on to the next one. Here is another one for you. I've got 2 square root of 3 times 5 square root of 2 minus 7 square root of 3. And I'll give you a little hint. After you distribute, after you multiply, there will be one of the radicals you can simplify on this one. All right, so let's take a look at this problem. So now I multiply stuff outside the radical with other stuff outside the radical. So for my first term, I've got 2 square root of 3 times 5 square root of 2. What's outside the radical on this one? 2 times 5 is 10. What's under the radical for this one? 3 times 2 is 6. Great. Outsides with outsides, unders with unders. Minus, what's outside the radical on the next one? 2 times 7, 14, yeah, with that negative. And then what's under the radical now? Great, if you got that, you've done 100% great job. Now don't forget, we simplify any radicals we can. What does square root of 9 simplify to? So the square root of 9 becomes 3, that's not a plus, that's a minus. Square root of 9 becomes 3. And so then negative 14 times 3 becomes, is that 42? Negative 42. Here's another one, so you can practice doing that again. Once again, in this problem that I give you, one of the radicals will simplify in this one as well. So I've got 2 square root of 5, 6 square root of 7, minus 2 square root of 3, plus 4 square root of 10. So multiply, and then one of the terms will simplify. let me get started. Check your numbers with my numbers. If we differ, let's talk about it. So 2 square root of 5 times 6 square root of 7. 2 times 6 is 12. Square root of 5, square root of 7, square root of 35. So that's good. 35 is not going to simplify. Minus 2 square root of 5 and times negative 2 square root of 3. 2 times negative 2 is negative 4. Square root of 5, square root of 3 is square root of 15. Again, that's good. It's not going to simplify. The last one, 2 square root of 5 times 4 square root of 10. 2 times 4 is 8. Square root of 5, square root of 10 is square root of 50. If you got there, you did fantastic. Just one little detail not to forget. We've seen this number pop up before. As you do enough problems, the numbers will become familiar because they repeat a lot. So square root of 50 is 25 times 2. I'm going to leave this. I'm going to just write over here. The product rule of radicals says I can give them each their own radical. And then what's the square root of 25? 5 times the 8 is 40 square root of 2. There's your expression after you multiply. One more, and then I've got a stopping point. We're going to finish talking about multiplying in today's class. And then when we come back on Monday, we'll finish dividing. It won't take us long. There's actually no real division in dividing. Then we'll talk about the last section, 7, and then there's one more thing, an 8.2, very quick section that'll allow you to solve any quadratic equation. So that'll be how we end up our time. So we have, after today, we have one more class of material. So we're almost to the finish. So here's the last one of these, 6 square root of x times 3 square root of y plus square root of x. All right, so multiplying here, 6 square root of x times 3 square root of y. The outsides, 6 times 3 is 18. The stuff under the radicals, square root of x times square root of y is the square root of xy, all under one radical. Nothing simplifies there. That is good as gold. Now on the other one, 6 square root of x times the square root of x. Well, 6 times the 1 outside, that's 6. Square root of x is square root of x times x, or x squared. So again, if you did that, you're doing a great job. If you didn't get that, you have a question, you don't see it, or why you missed it, then let's talk about it. The only other thing to do is this. What is the square root of x squared? How does that simplify? All right, so one more thing for the day, and then we will call it day. We've accomplished a lot today, so we're doing good. So the last thing is this. Again, we're walking down memory lane. This is something you've done in your algebra past somewhere along the way. Let's say that we have this. Let's say we had 2x plus 3 times, let's say, 5x minus 1. And we were multiplying those two things together. What would we do to multiply those two things together? Yes. We would distribute, and then what we come up with, probably at some point what you've heard, is because of the distributive property, when we apply it, we have to multiply every pair of terms together. And so we came up, somebody in your past has said the acronym FOIL. We FOIL these two things together, which is just the distributive property being applied. So we're going to FOIL these. First outers, inners, lasts. And when we do that, the firsts, 2x times 5x is 10x squared. My outers, 2x times -1 is -2x. My inners, 3 times 5x is 15x. And then my last, 3 times -1 is -3. And then the very last thing that we do is we collect some like terms, if there are any. In this case, there are. -2 and 15 is 13 of them. And there we go, we're done. And again, the reason I bring up this blast from the past is here's my last example for the day, and then I'm just going to have you do, we got about 15 minutes left. I've got 4 or 5 for you to do. That's how we'll end. So here's my last example for the day. Square root of 5 plus 3 times square root of 6 plus 1. Got 2 binomials. We're going to FOIL. So again, that's not new. Hopefully you remember that. That's an introductory algebra thing from way back, doing a little foiling. What is new is what we talked about at the very beginning today, the product rule. You multiply stuff under the radical only by other stuff under the radical. Okay, just like we were doing when we distributed. So here we go, my foiling, my firsts. Square root of 5 times square root of 6. What do I get when I multiply square root of 5 times square root of 6? That is indeed true, square root of 30. They're both under the radical, so we can multiply those numbers together. My outsides, square root of 5 times 1. The square root of 5 times 1 is just 1 times anything is the thing. So square root of 5 times 1 is square root of 5. My insides, the 3 is outside the radical times the square root of 6. What's 3 times the square root of 6? 3 square root of 6. Yes, it's not square root of 18 because the 3 is not under the radical. Okay, so don't be fooled there. You multiply stuff under the radical by other stuff under, the stuff outside by other stuff outside. No crossover. And then last but not least, the last 3 times 1 is 3. None of these are like terms. None of these simplify. We're done with the problem. Here's one for you. Same sort of thing. Just going to FOIL first, outers, inners, last. You're multiplying these 2 binomials together. So yours looks like this. 7 minus the square root of 3 times square root of 5 plus square root of 2. All right, first, outers, inners, last. Here we go. My first, 7 times the square root of 5. The 7 is outside the radical. The 5 is under the radical, so there's no crossover. So 7 times the square root of 5 is just 7 square root of 5, not the square root of 35. My outers, the same thing, 7 times the square root of 2. The 7's outside the radical. The 2 is under the radical, so that's 7 square root of 2. My inners, now both my inners are under radicals, so I have a negative square root of 3, square root of 5 is square root of 15. And then last but not least, square root of 3 times square root of 2 is negative square root of 6. Once again, nothing simplifies, so I am done with that problem. Those 4 terms are my answer to that. Try this one, see how you do. I've got the square root of 6 plus the square root of 2 times the square root of 6 minus the square root of 2. So my first square root of 6 times square root of 6, they're both under the radical. That becomes the square root of 36. My outers, square root of 6 times negative square root of 2. Well, first a positive times a negative is a negative. Square root of 6, square root of 2 is square root of 12. They're both under the radical. The inners, I have a positive square root of 2 times positive square root of 6. A positive times a positive is positive. Square root of 2, square root of 6 is square root of 12. And then finally, last but not least, positive square root of 2 times negative square root of 2. Positive times a negative is negative. Square root of 2 times square root of 2, they're both under the radical. It's square root of 4. Two things happen here. First, I have like terms. My square root of 12s. I have a negative square root of 12, a positive square root of 12. What happens to the square root of 12s on this problem? They cancel. See you later. There's a positive one, there's a negative one. Gone. And then my first and my last, those radicals can simplify. The first, what's the square root of 36? My last, what's the square root of 4? 6 minus 2 is 4. Now, if we were going to finish up this section today, we would apply this right away. So for now, you just have to put an asterisk in by it. And when we come back on Monday, we'll talk about it. These two things, they're going to have value to us when we go to divide, okay, which actually does not involve any division. When we go to divide radicals, these two things have value to us because notice they're the same two terms. The only difference is one has a plus between the two terms, the other has a minus. When that is the situation, these two things, I don't quiz you on these things. I'm just letting you know that they have a term. These two things are called conjugates. And they'll have value for us. We'll be able to use conjugates as a tool in the process of division. Okay, so we have time for either one or two more. It just depends on how long this one takes. So here is either your last or second to last problem of the day. Multiply these two things, and then notice a couple of the radicals will simplify on this problem. So here you go. You've got 4 square root of 2 plus the square root of 3. That's your first. And then you have 5 minus the square root of 6. That's your second one. So I'm going to FOIL, first outers, inners, lasts. So this will be our last problem. So if you have any final wrap-up questions or anything that we need to address before you go away for the weekend and do your homework, please let me know. So the first 4 square root of 2 times 5. Now this time I've got the 4 outside the radical. I've got the 5 outside the radical. So 4 times 5 is 20. And then I've got the square root of 2. So there's my first term, 20 square root of 2. That radical is not going to simplify. We're good. My outers, I've got 4 square root of 2 times negative square root of 6. So a 4 times a negative 1, that's a negative 4. That's the stuff outside the radical. Then the stuff under the radical, square root of 2, square root of 6 is square root of 12. We'll come back to that. Square root of 12 does simplify, so we'll take care of that in a moment. My insides, square root of 3 times 5, those are not both under the radical. The 5 is outside, and then the square root of 3. And then finally, my last, I've got positive square root of 3 times negative square root of 6. A positive times a negative is negative. Square root of 3, square root of 6, square root of 18. Now that will simplify for me. So my 20 square root of 2, nothing to do with that. What's my perfect square factor of 12? 4 times 3. And then what's my perfect square factor of 18? 9 times 2, indeed. Product rule of radicals says I can consider that 4 separately. What's the square root of 4? 2 times the 4 that's already outside. So the square root of 4 is 2 times this 4 becomes what? Product rule of radicals says I can consider that 9 separately. Square root of 9 is 3. And last but not least, you've multiplied, that's great. You simplified the 2 radicals that can be simplified, that's great. Last but not least, a couple of those turned into like terms. So I've got 20 square root of 2 over here at the end. I've got minus 3 square root of 2, so that's 17 square root of 2. And then I've got negative 8 square root of 3 plus 5 square root of 3, that is negative 3 square root of 3. Those are like terms. So that problem right there, you followed along with it, you go do your homework, and that involved pretty much everything we've talked about today. Okay, it involved the product rule of radicals and being able to simplify. It involved multiplying radicals and foiling. It involved collecting the like terms. So that problem had a little bit of it all.